so I'm going to do a little practice here on some functions. I'm going to find y prime of the given functions. Work from top to bottom. As I get them done, I'm going to cross them off. So the first one is y equals cosine of tangent x. All right, you have to know that the derivative of cosine is negative sine, and then you see that this is a product rule, or a chain rule. You see that y could be written as f of g of x, where f of x is cosine x, and the inside is tan x. All right, again, we know the derivative of a chain rule where it's this is simply f prime g times g prime. I dropped the x's here for simplicity's sake on the right side. So I'm not going to use the rule. I'm going to just start with, I know the derivative of cosine is negative sine, and the argument never changes, so it stays tangent x. Then I just have to take the derivative of tangent x, which I know is secant squared x. And that is the answer to the one at the top. Y equals that. So I'll shrink that down. And I'll just erase all that. My board's being a little finicky. So that's the first one. Pause it, rewind if you need. Next one, I see a quotient rule. F, G, and G is going to be a chain rule again because it's 2x to the plus 1 raised to the half power. So to help us see that, I would write this as 3x minus 2 over 2x plus 1 to the half. All right, quotient rule, derivative of the top, right? 3 times the bottom minus the top times the derivative of the bottom, which is a little more complicated. The half comes down, reduced by a half, negative half, times derivative inside. Derivative of 2x minus 1 is simply 2. All over the bottom squared. And again, I'll write it out so you guys see it, but a half times 2 is going to be just 2x plus 1. This is a problem that you would often have to simplify, so I'm going to simplify it. 2x plus 1 minus 3x minus 2, and the half and the 2 will cancel, and that radical goes here. And now I'm going to need a common denominator in the numerator. And when I do that, I'm going to get y prime equals 3 times 2x plus 1 minus the quantity 3x minus 2, making sure not to lose that the negative is going to distribute, so I show the brackets there. All over the square root of 2x plus 1, all over 2x plus 1, but that will flip up and be in the bottom here. Because I can multiply at this point. You're not seeing this. This is algebra. This is not calculus at this point. All right, that'll cancel this bottom, and then that'll bring in the bottom. Now it allows me to write this. 6x minus 3x, I get 3x. 3 plus 2 is plus 5. And the bottom is 2x plus 1 to the 3 halves. Because this is a half power, this is a 1 power. 1 plus a half is 3 halves. And that is y prime for the second problem. I like the third one in this list. It's interesting. All right, so I'm going to make it bigger. I do not want my students doing a quotient rule on the inside of this. First thing I want them to do is rewrite this like this. And now it's a chain rule. Bring the power down and reduce it by 1. So y prime is square root of 7. I don't care what it is. The inside doesn't change. And I can't combine them, so I'll just write it as square root of 7 minus 1. Times the derivative of the inside. Well, derivative of x is 1. Derivative of x to the negative 2. Negative 2 comes down, and then reduce the power by 1. And that is the answer. I'm already done with the third problem. Fourth one. Boy, that's similar to the first one. Fourth fourth one here is simply a chain rule. I'm going to do it rather quickly. Y prime equals derivative of sine. I know it's cosine. Argument doesn't change. That cosine x, this argument stays the same. Times now the derivative of cosine. Derivative of this cosine is negative sine x. So the answer is cosine of cosine x times negative sine x. All right, now the next one's interesting also. I would tell my students, hey, I don't want to do the quotient rule on this because I have the opportunity to bring up this entire thing. So I would write this as y equals sine of, I tell you what right away, my argument is always going to be this x minus sine x. Now I'm going to raise that to the negative 1. Now I'll take the derivative. Power comes down, negative 1 times sine x minus sine x to the negative 2. All right. When I do that, I shrink this down a little bit. All right. That's going to be times. Now I'm going to take the derivative of this. Derivative of sine is cosine. The argument doesn't change. I'm going to need another link in the chain rule here. This is negative sine x. Got a little dead spot going on. All right, and I'm going to shrink this down a little more. Shrink it a little more so that fits. And then I got to take the derivative of x minus sine x. I'll do that again here. I'll do it in a different color. I got to take the derivative of this. Sometimes derivative of x is 1. Derivative of sine x, we know is cosine x. So, again, a lot of steps. I'm going to erase this, make it a little cleaner. That's just the argument, which we know is never going to change. I can't stress that enough to my students. We knew the argument on all the trig functions would be the same, and it is. It's x minus sine x because that was what was there originally. And you notice at the very end, there's an argument on this one, and that argument's the same also. All right? You can't get those arguments if you never divide by it. You can't do any tricks to it. All right? If you do the product rule, you will get the same answer. I think my answer is just a little easier to do. Or quotient rule, I mean. I did the chain rule. All right, next one, y equals secant of 1 plus x squared. All right, so we know the derivative of secant is secant tangent. Don't overthink it. So write secant of stuff, tangent of stuff. The stuff doesn't change. The stuff is 1 plus x squared. Now he's got to multiply by the derivative of the stuff. The stuff is, derivative of 1 is 0, derivative of x squared is just 2x. And that's the answer. So again, a lot of times on multiple choices, they'll look like this. Obviously, they'll move the x squared. It's a good time to talk about that. But again, I am just right now trying to make sure you master these concepts. And again, this comes with practice, everybody. All right. The next one. Ooh. All right. Next one is a differential. And you can see right away, x and y, that's going to be a product rule. X and y, that's going to be a product rule. Sine of 2y is going to be the chain rule. So we're going to have all this stuff going on. So I'm going to start with x squared cosine y. All right. So I'm going to start with x squared cosine y, like I just said. Got a little pause there. So I see, I'm going to take the derivative. I'm going to call this f. I'm going to call cosine yg. So I'm going to take the derivative of f first. I'm going to say derivative of x squared is 2x cos y. Now it is dx, but I'm dividing by dx immediately. Plus x squared, derivative of cosine y is negative sine y, dy, which we divide by dx to get y prime. That is the derivative of just the first term. All right? So I got that. And I'll make it a little smaller. And now I'm going to go to the next term. I'll do that in a different color. Plus, derivative of sine is cosine 2y. The argument doesn't change. Derivative of the inside is 2. dy dx is y prime. That puts me on to an equal sign. All right, I got another product rule. On the other side, I'll take the derivative of x first. Derivative of x is 1, so it's just y. Just y. plus, then the derivative of y is just 1, so it's x, y prime. All right, it asked me to solve for y prime. Well, there's a whole slew of them this time, and you got to find them all. You got to make sure you keep your terms pretty clear in your head. So I see 5 terms. I want to make sure we see 5. 1, 2, 3, 4, 5. This one, and this one have y prime. So 2 of them are on the left side already. So I'm going to send 2x cos y to the right, and I'm going to send y to the left. Now, everybody, this is algebra. This is no longer calculus, all right? So I have, if I bring xy prime to the front, I have x, negative xy prime, minus x squared sine y, y prime, plus 2 cos 2y, y prime equals, and again, I have the, I did this backwards on these yellow arrows here. I left y, I brought this over. All right, and I have y minus, and I bring over 2x cos y. All right, this is now a factor problem. The y primes, if you make this one thing, can be factored out, right? So my answer to this is y prime equals, and this is ugly, y minus 2x cos y divided by negative x minus x squared sine y plus 2 cosine 2y. And everybody, this is the answer to this problem right here. All right? It is a differential, and again, we skipped the step of writing dx and then dividing by dx on these steps where we took the derivative with respect to x. We just did y prime for dy dx on the y derivatives. Again, it takes practice, all right? So you have to go through and see this over and over. All right. All right. Now, I would tell my students next to, especially, it's just important that you write them out correctly. You have to see that there's probably either a quotient or we're going to move some stuff around on the next one. And I see this. I see x plus x to the half to the third for number, second to the last one there. And the first thing I would do is say, well, since it's 1 on the top, I can just bring it up. I don't have to make this hard. I can write it this way. The stuff inside to the negative third. So now the derivative is pretty easy. It's chain rule. Bring down the power. So y prime equals negative third. The inside stays the same. Reduced by 1 is negative 4/3 times the derivative of the inside. Derivative of the inside, derivative of x is 1. Derivative of x to the half is 1/2 x to the negative half. Now, again, I would argue this is probably a problem that you'd have to be able to simplify on multiple choice. Let's take a second and simplify this. It's kind of a pain. I'm not going to sugarcoat this, all right? So I'm going to write the first part here, y prime equals negative 1 on top, 3 on the bottom. And I'm going to move down and write x plus the square root of x. I'm going to change this back to x plus the square root of x. And I'm going to write this as the power of 4/3 for right now. Up here in the top, this is still times 1 plus 1 over 2 square roots of x. All right. I'm going to move down the page. I got some more simplification to do. So I would probably have to get a common denominator over on this one and write this as 2 square roots of x over 2 square roots of x plus 1 2 square roots of x. It's still times, and this probably go back to, on a multiple choice test, this absolutely could go back to this. It could absolutely go back to the radical and leave the 4 power inside. All right, not fun. All right, now this becomes a common denominator over here, so you can write this as 2 square roots of x plus 1 all over 2 square roots of x. It has a different power. So I wouldn't think they would make a big deal about this, and you still got the negative 1 times the numerator up there over 3 times the 3rd root of x plus the square root of x to the 4th. All All right, last step, I'll write it all together. Y prime equals negative 2 square roots of x minus 1, distribute the negative 1 to both these, over 3 times 2 is 6, square root of x, cube root of x plus square root of x, all to the 4th. And I suppose we should realize that this 4 could be here, or it could be out here, right on the outside of the radical. Doesn't matter where. And again, a big one. I mean, I just can't stress enough that these just get very long sometimes, all right? So again, all those steps to get us there. And realistically, the derivative was done here. Everything else was steps. All right. I don't think I'll need that much space. I won't have to worry about going that low. Let's erase some. You get 100%. 125%. All right, last one. Y equals sine. I'm going to leave it as square root of x for a second. Because what I want you to realize is that we're going to do the chain rule first. All right? Now I'm going to go y prime equals 1/2 sine square root of x to the negative half. And then I'm going to have to do the derivative of sine square root of x, which derivative of sine is cosine square root of x times. Now, finally, I'm going to take the derivative of square root of x here. So I'm thinking of it as x to the half. So my derivative, and I'll do this in a different color, my derivative here then is just 1/2 x to the negative half. And the chain rule has a couple links. And you notice I didn't have to worry about it. All right? So, and again, this is one that maybe gets reduced. All right? So this might become y prime equals 1/2 over 1 over the square root of sine square root of x. You notice it's the same function there. Times cosine of square root of x on the top. Times 1 over 2 square root of x. When you do all that work, you can see it kind of jumps out part by part. Now you can just multiply them. And I get cos x square root of x in the numerator. On the bottom, I got a lot going on. And since these are both radicals, I can make the 4 2 and 2, but I can bring that x inside if I want to go x sine of square root of x. The worst part for you on this one, everybody, is that if you leave the square root of x and the sine square root of x separate and do this, what's cosine over sine? Cosine over sine is cotangent. And it could be this on a multiple choice test. All right? So again, derivative is done. Simplification can be the hardest part. So you need to practice these against your answer books and your problem sets, all right? These take practice. Don't get too frustrated. And again, if you have specific questions, send it on to me. There were 9 in 18 minutes. Not too bad.